Today we're going to talk about series that go on forever, or infinite series. So if we look at the series going from 1 to 51 and it stops here, we call that a finite series, and we say it converges because it stops. It's convergent. If you see something going like this, 1, 2, 3, 4, 5, with a series of dots after, that means it continues forever, which means it's an infinite series, and we say that diverges. Let's take a look at some more. If we look at an infinite arithmetic series that diverges and goes on forever, you can't find a sum for this. We say there's no sum because it goes on forever. If we look at an infinite geometric series where our ratio is greater than 1, this will grow forever and ever as well, which means it goes to infinity, and there's no sum here as well. Now, if we look at this, where we have an infinite geometric series where there's a ratio less than 1, we notice these numbers are getting smaller and smaller. And these numbers will never go negative, because if you take half of a positive number, you're just going to keep getting smaller positive. And the question is, what happens to this? Is there a sum if we're adding less and less and less and eventually adding something really close to 0? Well, that's what we're going to look at. So we know that all infinite arithmetic series have no sum. We just talked about that. All geometric series whose ratio is greater than 1 in absolute value have no sum. And we look at all geometric series where the ratio is less than 1, and they actually do have a sum. In looking at our geometric series equation, we notice that we have a ratio raised to an n power, and if this goes on forever and ever, n is really like infinity. But our r in this case is less than 1. So if we take and raise a number less than 1, let's say a half, to the infinite power, if you pop that in your calculator, obviously you can't put infinity, but if you put a ridiculously large number in here, your calculator is eventually going to show 0. So what really happens is when I raise a number less than 1 to a very, very large power, this term is actually going to go away. And thus, our equation turns into this. And in actuality, the equation for an infinite geometric series where the ratio is less than 1 is indeed the first term over 1 minus the ratio. Again, only true when the ratio in absolute value is less than 1. So let's do some examples. We know here this is geometric. We're multiplying by 1 over 10 for our ratio. And if we want to find the sum of this, the infinite sum is equal to the first term over 1 minus that ratio. So this is 1/15 over 9/10, which is the same as 1/15 times the reciprocal 10/9. We get 2 over 27. And that's the sum for an infinite number of terms. Alright, so next, very similar problem. We just have to calculate the ratio, but notice on this example it alternates from positives to negatives. So our ratio is going to have to be negative in this case. And it is indeed, r is equal to, well, whatever negative 3 over 16 divided by 3 over 8 is. That's going to be negative 3/16 multiplied by 8/3, and in that case it's negative 1/2. So now I take my first term. If I want the sum of the infinite series, I take my first term, which is 3/8, divide that by 1 minus negative 1/2, which gives me 3/8 over 3/2, which equals 3/8 multiplied by 2/3, or 1/4. Next example. So we're back in sigma notation. Again, I'm going to need my first term. I know this is infinite. It appears to be geometric. We can check. Let's go ahead and plug in 1. When I plug in 1, I have 8 times 2/3 raised to the -1 power. That's equal to 8 times 3/2, which is 12. Then I plug in my next guy, which is a equals 2, and we have 8 times 2/3 to the 0 power, which ends up as just 8 times 1, or 8. Let's just do one more for kicks. A equals 3. We have 8 times 2/3 to the first power, which is 8 times 2/3, which is 16 over 3. So it appears I have 8 over 12 for my ratio, which is 2/3. If I multiply 2/3 by 8, I get 16 over 3, so that is my ratio. So now let's go ahead and find that sum. We take our first term, which we said in this case was 12. Put that over 1 minus our ratio, which is 2/3. And that's equal to the infinite sum. So that's 12 over 1/3, which is 36. Let's do another one. In this case, n is equal to 2. That's okay. It's still the first term in our sequence. So in this case, we have n equals 2, but this is our first term. So we have 1/2 times 4/5 squared, which is 1/2 times 16 over 25, or 8/25. And then our next term, we're going to plug in a 3, is 1/2 times 4/5 cubed, and that's going to be a total of 1/2 times 64 over 125, which is 32 over 125. And I just look right now, and it looks like this ratio is going to be 4/5. We can plug another one in just for kicks. So at n equals 4, I raise that, and I have 256 over 625 times 1/2, which is 128 over 625, and sure enough, r is equal to 4/5. So the sum of my infinite series is that first term, which is 8/25, over 1 minus my ratio of 4/5, which is 8/25 over 1/5, which is 8/25 times 5, or in this case 8/5. So this problem is a little more difficult to work out. I could do this simply in our calculator by going 0.15151515, use about 3 lines of that, and then hit math frac, and it'll get it for me. But if I don't have a calculator, which you wouldn't have when I do a problem like this, you're going to have to figure out another way to get this done. So I'm going to look at this repeating decimal a different way. I'm going to look at it like this. I'm going to say that this is 0.15 plus 0.0015 plus 0.000015 forever and ever and ever and ever. Alright, well 0.15 is basically 15 over 100. 0.0015 is 15 over a total of 10,000. And the next term is 15 over, what is that, a million, etc., etc., etc. So in this case, I have a repeating pattern, and in that repeating pattern, I'm having a ratio of, if I take 15 over 10,000 divided by 15 over 100, I end up with a ratio of 1/100th. So now I can figure this whole problem out. I know that my first term is equal to 15/100ths over 1 minus a ratio of 1/100th, which is 15/100ths divided by 99/100ths, or 15/100ths multiplied by 100 over 99, which is 15/99ths, which of course reduces to 5/33. And that's my repeating fraction. And that's all we've got. Make sure you do your Connect Ed and fill out your lesson summary, and we'll talk to you tomorrow.